You have decided AI belongs on a job and you know how to place it. Now comes the question the IT and finance sides will both ask. Where does it actually run? On somebody else's cloud or on a box inside your plant? This is not an easy question, but it comes down to a straight trade-off, and in a plant, your data usually decides it for you. Every deployment choice is a tug of war between three things. Capability, how powerful and up-to-date a model you can use. Control, how much your data and your systems stay in your hands. And cost, both the upfront kind and the ongoing kind. Here is the catch, you rarely get to max out all three at once. Push for the most capable model on top, and you usually give up some control. Lock everything down on site, and you take on cost and maintenance. So the real skill is not picking a favorite, it is knowing which corner this particular job cares about most. Start with the public cloud, an AI service you call over the internet. It is the fastest way to start, no hardware to buy, and you get the latest, most capable models the day they ship. For a lot of office-side work, that is exactly right. But look at the trade. Your data leaves your walls to get answered. The bill is variable, it can climb fast as usage grows, and you are locked into that vendor's platform. None of that is a deal breaker for reading public manuals. It is a very big deal for your crown jewel data. Now the opposite end, on-prem or edge, AI running on your own hardware at your site. Here your proprietary machine data and your IP never leaves the building. Cost is predictable once you have bought the hardware. And latency is low, even on a line that is disconnected from the internet. There is a compliance angle too. If you operate in Europe, the EU AI Act adds obligations for higher risk AI, and data protection rules govern where sensitive data can go. So keeping data and control in-house can make "is this even allowed?" much easier to answer. The price? Real capital upfront, you maintain those GPUs, the graphics chips that run the models, yourself, and it strains when load spikes. And the one people underestimate most, the models you can realistically run on your own hardware are smaller and less capable than the frontier models on the cloud, for a specific, well-scoped job that is often perfectly good enough. More capex buys a better local model, and better again. But even the best you will run on site still will not match the very top cloud models. And if you want something in between, private cloud gives you cloud scale, but in your own walled-off tenancy, a middle ground. So it is a spectrum, not two boxes. So there is no universal right answer. There is a right answer for each job. Watch the seed plant decide. Its shop floor question and answer assistant, reading public manuals. Cloud is fine, fast and cheap to start. But its proprietary seed genetics and its machine performance history, the crown jewels, those lean on-prem or private, so the IP never leaves sight. Same plant, two jobs, two homes, and the data made the call, not the trend. There is one more thing that tilts this though. The plant floor itself plays by different rules than the office. An office app can hang for a second and nobody gets hurt. You just wait. A control loop cannot. That one difference between your office network and your plant floor decides more about where AI can go than any spec sheet. So before we talk about what pays off, let us be clear about the ground it runs on. Your plant really has two worlds. The office side, IT, information technology, runs email, ERP, and dashboards. If it is slow for a second, you shrug. The plant floor, OT, operational technology, is sensors, PLCs, and drives, the bagging line running in real time. Out here, three things are not optional. It has to respond instantly, it cannot go down, and it cannot do anything unsafe. Latency, uptime, safety, on the floor, those are not features. They are the entire job. Here is the consequence, and it is the important one. The smartest, most capable AI model you can buy often cannot sit on that real-time control loop. 3 reasons. It is too slow for a loop measured in milliseconds. It is not perfectly predictable, and control has to be. And, as we saw earlier, it can be confidently wrong, which is merely awkward in an email and genuinely dangerous on a machine. So, on the floor, that is the same boundary we drew before. The real-time control loop stays deterministic, and AI advises the people and the automations that run it. But that fence is narrow. It is the loop, not the whole floor. Now you know why the floor draws it. So that is the ground rule. The plant floor is real-time and safety critical, which is why AI advises there rather than running the loop, not a lack of ambition, just the nature of the floor. But do not mistake that one fence for the whole floor. All around the loop, AI already does real, valuable work. Narrow machine learning ranking the best option for an operator mid-decision, predictive AI flagging the machine that will fail before it does. And when there is time to think, not milliseconds, a language model making sense of a messy situation. Those are genuine wins. Strip away for a second what is trending. Where is AI already making manufacturers money today at scale with numbers solid enough to put in a business case? The honest answer is a little boring, and honestly, that is exactly why you can trust it. Two wins dominate, and neither of them is a chatbot. Win number one, predictive maintenance. It is narrow machine learning watching your equipment's own data, vibration, temperature, current, to catch a failure before it happens. The numbers come from published deployments, and they are ranges, not promises. Roughly 20 to 40% less unplanned downtime, 25 to 40% lower maintenance cost, and fault scout 30 to 50% earlier than a fixed threshold alarm. And the sensors that feed it now cost cents apiece. That is not a demo, that is a business case. Win number two, vision quality inspection, a camera plus machine learning, checking every single unit as it passes, never blinking. In published deployments, that is caught defect rates by around a third. Think what that means downstream. Fewer bad units shipped, fewer complaints, fewer returns. It is the same seed grading camera we met earlier, and it is quietly one of the most reliable AI investments a plant can make. Now, notice what these two have in common, because it is the whole point. Neither one is generative AI, neither one chats. They are both narrow machine learning, the quiet workhorses from earlier doing the math. This is machine learning doing the math, cashing out in real money. The lesson for your business case is blunt. Today, the proven, bankable AI in a plant is the unglamorous, narrow, data-driven kind. Boring is bankable. So, what pays off today in plain terms? Predictive maintenance and vision quality inspection. Narrow machine learning with numbers you can defend. The market is real and growing fast, but the proven return lies in those boring, narrow wins. Now, that does not write off generative AI, it just puts it in its place. The language model has genuinely found its lane. The language and the judgment work, drafting, summarizing, helping you reason through a one-off problem, always with a person checking. It is simply not where the hard ROI numbers sit today, and it is not for the jobs that have to be guaranteed correct and safe. Those stay with machine learning and plain optimization. So the real question is not machine learning or the language model. It is giving each the job it is genuinely good at and putting the language model in the right place. That leaves one honest question about the language model, where it actually belongs and how to put it to work. So here is the sharper question about the shop floor itself. Does a language model actually belong down there? And if so, how? It is tempting to just let it run the place, drive the line, be the operator screen, answer every question live. But the pattern that keeps winning flips that around. Not AI to run the floor, but AI to build what runs on it. Start with running the plant. You could wire a language model straight into your subsystems and let it drive. And yes, it would work a lot of the time. But it is non-deterministic, it will occasionally be wrong. And occasionally wrong is the one thing your line's driver cannot be. So flip it. Do not make the language model the driver. Use it to help build the driver, to engineer the deterministic automation that then runs predictably every cycle. And because this is a safety critical plant, the building is supervised. A person reviews and tests what the language model produces before it goes live, exactly like any engineering project. The language model makes delivery fast. The human keeps it safe. Same idea for the operator interface. It is tempting to make a chatbot the way people talk to the plant, just ask it anything. And for some questions, that is lovely. But think about a control room. An operator does not want to type a question to find out if the line is healthy. They want to glance and know. A well-built dashboard, live numbers, always on screen, the same for everyone, often serves operations far better than a chat you have to requery every time. Use the language model to help build the dashboard maybe. Just do not make the chat the only door in. One more, and it is the one that quietly saves the most. Say, everyone wants the OEE analysis, the line's headline health score. You could have people ask the language model for it fresh every single time, and every time it rereads the database, rethinks, and rewrites the answer. That is a person's time to ask, and real compute and energy to answer, over and over. And you might get slightly different answers each time. Or you have the language model help build one clear report, once pulling from the same data, laid out the same way, and everyone just opens it. Generated once, reused by all, cheaper, greener, faster to read, and consistent. Build the artifact once, do not rebuild it on every request. So, does the language model belong on the floor at all? Yes, just not everywhere. The trick is to match the job. Take the routine, day-to-day work, tracking OEE every shift, flagging a drift, holding a threshold. That is routine and repeatable, and it is better done by narrow machine learning or predictive AI, set up once, fine-tuned, and it runs efficiently and accurately. Do not spend a language model on it. But now flip to the judgment calls, the non-routine questions. OE on the begging line just dropped. Why? That is exactly where the language model earns its place, but not a bare language model. What makes it powerful here is everything you connected to it earlier, your data, your context, your knowledge, grounded on the knowledge graph, reaching your systems through MCP using the know-how you packaged. And that connection is engineered and architected upfront. It does not come for free. Given that, it can summarize the whole dashboard in plain words. Build a plan of action and pull the pieces together from your reports and that grounded knowledge. For the messy, one-off, help me figure this out work, it is genuinely powerful. Routine runs on machine learning. The judgment calls get the language model, grounded in your data. So, the answer to the question we opened with, should a language model be on the shop floor? Yes, for the right jobs. 3 things to carry out of this. 1. Use it to build, not to run, and supervise the build. A person reviews and tests what it makes. 2. Match the job. Routine, repeatable work runs on machine learning, and the judgment calls and the messy analysis get the language model. 3. Whatever it builds or advises, a human owns it and stays accountable. Used that way, the language model is a real accelerator, fast delivery, real help, without ever becoming the thing you cannot trust to run alone. That closes out where AI runs and what pays off. What is left is the part that ties it together, where all of this is heading, and a simple way to decide for yourself.